Introduction to Organic Chemistry. So we're going to be using the IUPAC system in terms of following the rules for naming compounds. And again, some of these compounds will have common names, but we want to be able to for sure name them under the IUPAC system, if not also by the common name. We're going to start off with alkanes, which are saturated hydrocarbons, meaning that they're made of hydrogen and carbon, and all the carbons are single bonded to each other, and the other bonds are filled out with hydrogens. So each of these carbons we know will be forming 4 bonds, and for an alkane, and again it's got that ane ending, it's going to have 4 bonds on it. The carbons are going to be bonded to each other, and then the rest of the bonds will be held up or filled out by the hydrogens and saturated by them. That's why they're called saturated hydrocarbons. So we're going to look at a couple of different diagrams. There's a full formula diagram where you're sort of showing all of the bonds and all of the atoms connect to each other. We can condense that a little bit by not showing exactly how the hydrogens are bonded to the carbons, but instead just saying how many are connected to each carbon. And then if we want to get into the actual shape of the molecule, we can use things like ball and stick models or space filling models. Often the condensed formulas, they take up a lot of space on a page if you branch them out like that. And so instead, where the branches are, we put those carbons in brackets. So this branch up here is the carbon that is in brackets. This branch here, there's 2 carbons that are along that branch. And so there's a bracket here coming off of the 3rd carbon in the chain. So 1 carbon, that's this guy. 2 carbon, that's this guy that has a branch on it. The 3rd carbon here also has this branch on it, which consists of 2 carbons with their hydrogens. And then there's 3 carbons at the end. These are these 3 carbons here in the chain. So this is a lot easier to fit onto a page and then just write fairly concisely. We also want to be able to draw them and get that drawing done really quickly. So we're going to use what's called line diagrams. So imagine a pentane molecule with 5 carbons. We can draw a structural diagram that shows everything on it, all the hydrogens, all the carbons, or we can draw a line diagram. And essentially what we're doing is we're showing these lines here, and we've kind of got the angles. We try to represent what they would actually look like around each of these carbons. So there's these carbons here, and we have tetrahedral shapes around each one of them. So that ending there and these corners here are where the carbons are. So essentially a line diagram just shows the bonds between the carbons, and it doesn't show that there are hydrogens also bonded on those carbons, which there are, but a line diagram doesn't bother showing that. So when you look at a line diagram, you have to be able to pick out where all of these extra hydrogens are without them actually being shown. Branched alkanes, we've got to figure out, okay, we've got a certain number here that are in a row, and that's going to be the basis of what we're going to call our parent or our main chain. And so essentially we're looking for the longest continuous chain. That will be the parent, and then whatever else is hanging off of it, we'll consider that a branch. So in this one, we don't just have 1, 2, 3, 4 carbons as the parent. We do have that, but not that alone. So we do have these 4 carbons here. So that is butane, but it's not just butane because it also has this branch on it. But when we get into naming these, we have to be able to pick out the main chain or the parent, and then we'll get into naming the branches on those as well. Let's look at some of the names first. So we need to make sure we know the prefixes for the number of carbons. If there's 1 carbon, we use the prefix meth. If there's 2 carbons, we use eth. 3 carbons is prop. 4 carbons is but. And 5 carbons is pent. After that, you probably recognize all of those prefixes either from when we're doing binomial molecular compounds, binary molecular compounds, sorry, or from your shapes. But if you don't know these first 5 already, you need to make sure you know what they are called in terms of the numbers of carbons. If they are alkanes, then we end with ane. So 1 carbon, obviously it wouldn't have anything bonding to it, so we just call that one methane. If you have 2 carbons, and as long as they're not double bonded or triple bonded to each other, we call it ethane. The smaller guys are going to be, so anything below pentane and below is going to be a gas at room temperature because it has relatively low London forces. But as you get bigger, you're going to have greater London forces, and so these larger molecules end up being liquids at room temperature. Their boiling points is going to look something like this. So as the molecule gets bigger, the boiling point is increasing. It shows this curve here. But again, as we go from something that's relatively small up to something that's relatively big, none of these are polar, but these larger molecules are going to have more London forces and hence a higher boiling point. So the rules for naming these branches that we saw earlier. Now that we know the names of the numbers of carbons, we can start dealing with the rules for naming them. So the first is to find that parent chain. Where is the longest continuous chain? That's going to be the root of the name. The number of carbons that are in that chain, we're going to actually give them a counting system. So we're going to number them 1, 2, 3, 4, whatever, however many there are. And what we want is wherever the branch is, we want the first carbon to be near that branch. The branch themselves, we're going to look at how many carbons are on them. And because the branch is attached, we're going to use ol as the ending. So we're going to say how many carbons there are, and then we're going to say ol. So for example, if there is a single carbon branching off of the main chain, we will refer to that as a methyl branch. If there's 2 carbons branching off the main chain in a row, so a line of 2 carbons, then that would be an ethyl branch. If there is more than one, we are going to place their names alphabetically as well. So for example, if there is an ethyl branch and a methyl branch on the parent chain, we would put the ethyl branch first because the E comes before M. And if there's more than one of them of the same type, we're going to use prefixes to say that. So for example, if there's 2 of these methyl branches, we're going to say dimethyl in front of the branch name. These numbers tell us where the branches are. So this is going to be the parent at the end here. And you want to look at, when you're drawing these, you want to look at the name and you want to find the parent first and say, okay, I'm dealing with pentane, and then there's this other stuff on pentane. So you'd want to start by drawing a line diagram for pentane, so 5 carbons. And again, remember, the carbons are on the end here, so 1, 2, 3, 4, 5, but we don't want to actually draw the carbons when we're doing our line diagram. So realize they are there, realize that they have the hydrogens bonded to them, but we're just going to draw the line diagram for it. Now, since we're drawing it, I can decide if I should make this carbon number 1 and this one number 2, or if I want, I could say, okay, let's make this carbon number 1 and this carbon number 2, and so on. But I'll just start from left to right. 1, 2, 3, 4, 5. So just numbering my carbons, because I know that on the second carbon, so there's carbon number 1, there's carbon number 2. On the second carbon, there is a methyl branch. And so I can draw a branch that consists of 1 carbon on it. So a bond will be connecting that carbon to the parent chain. It is on the second carbon, and it is a methyl branch. There's also another thing on the second carbon that is, as says dimethyl, also a methyl branch. So essentially on the second carbon, there are 2 methyl branches. That's what this is saying. On the second carbon, as well as on the second carbon, they do mention the number twice for each of the branches. We mentioned the number that it is on, even if it is the same number. We would say 2,2-dimethyl to say that on carbon number 2, there are 2 methyl branches. And there's a slightly better angled expanded diagram. All right, with this one here, we want to look at, again, the parent chain. So look at the end of the name and say this is, okay, this is heptane. So I want to draw this out, 1, 2, 3, 4, 5, 6, 7. And then I can start putting the branches in. I'll again start carbon number 1 there, 2, 3, 4, 5, 6, 7. You don't have to number them as you're drawing it, but it can help as you're starting out when you're doing this. So I know that on the third, because remember the numbers tell you which carbon it is. So I know on the third carbon, there's an ethyl branch. And an ethyl branch consists of 2 carbons. There'd be 1 carbon, 2 carbons, and then it would be attached to the main chain. So I want to make sure that on my third carbon, I draw, there's 1, 2. And if I can get them in the right spot there. Let's fix that. So on the third carbon, there is 1, 2 carbons attached there. That is my ethyl branch. So if I circled it, this is an ethyl branch. It consists of 2 carbons. And they are on my third carbon of heptane. So the numbers are referring back to where on the parent the different branches are. And let's do this next one in purple. On the second carbon, so here's another number referring to the type of branch here, and I have 2 of them again. On the second carbon, I have a methyl. So I'm going to draw a branch that's connected to my carbon. So that's, and again, we don't normally put them as circles, but there's a bond leading up to that methyl branch. And the same thing on the fourth carbon, there's a methyl branch. There's two methyl branches, one on the second carbon and one on the first carbon. So there's another one there. And again, these are my methyl branches. So this is a methyl branch, and this is also a methyl branch because they consist of one carbon. That's also a one carbon branch. Down here, this is a there's two carbons, and it's a branch, so we say ethyl. So we have a methyl branch and a methyl branch and an ethyl branch, and we know there are ethyls on the third carbon right here, and our methyls are on the second and the fourth as well. So we end up with 3-ethyl 2,4-dimethyl-heptane. All right, with this one here, we have an octane. So 1, 2, 3, 4, 5, 6, 7, 8. So there is our octane. So again, look at the name, start with the parent, and then figure out what is on that parent. And so here I have, there's 3 methyl branches, and they are on carbon number 2, number 3, and number 3. So let's try not numbering this time, but we know that this is our first carbon. I'm choosing to start on the left. I could start on the right, and this could be my first carbon over here, and this could be my second carbon, but I like writing left to right, so I'm going to start with this carbon being carbon number 1, which means this is carbon number 2, and I know this tells me on carbon number 2 there is a methyl branch. So I have taken carbon number 2 and I've put this methyl branch on carbon number 2. I know that on carbon number 3, and this is 1, 2, 3, so on carbon number 3 there's another methyl branch, because that's what the name says, that on carbon number 2 and carbon number 3 there's a methyl branch. And so there's that one done. There's another on the carbon number 3, another methyl branch. There's 3 methyl branches, trimethyl, on 2, 3, and 3. So I'm going to draw another line here on carbon number 3, which is my third, that's another single carbon branch. So that's my third methyl branch. And this is why it's called trimethyl, because there's 3 methyl branches, and they're on 2, 3, and 3 of the parent. Next we have a propyl branch. So that's 3 carbons, and it is on carbon number 4. So I'm going to count in 1, 2, 3. I know that this is carbon number 4, and I'm going to draw a propyl branch. I'm kind of running out of space here. Let's clear this up a bit. And so on carbon number 4, I have a propyl branch, 1, 2, 3, and that consists of those 3 carbons there. So again, those 3 there are my propyl branch, and that is on carbon number, if we were to look at these 1, 2, this is carbon number 3, so that would be carbon number 4. And so there is my 2,3,3 trimethyl 4-propyl octane. So the 2,3,3 trimethyl tells you there's 3 methyl branches on carbon number 2 and number 3, and again on number 3. The 4-propyl tells us that there's a propyl on the 4th carbon, and it is a 3 carbon branch. That's what the propyl means. So let's start off with a line diagram, just so we can look at this as a line diagram as well. And so the first part is to find the longest continuous chain. And so I could say, all right, if I've got 1, 2, 3, 4, 5 carbons in a row, that's the longest chain. Or I could do 1, 2, 3, 4, 5. And so either one of those would work. So let's say this is the longest continuous chain, but I could also, that's 5 carbons in length. I could also say, okay, well, I could count this as the longest continuous chain. That's also 5 carbon in length. It wouldn't matter, it'll give us the same name. Then I should recognize the branches I'm dealing with. So I have a methyl branch here, and up here I have another methyl branch. And so I know that I'm dealing with a 5 carbon, so let's write out the parent there. So this is 5 carbons, so we call it pentane. There's no double bonds in it, so there's 5 carbons, all single bonded together. And I know that I've got dimethyl on it because there are 2 methyl branches on there. Now I want to number where these methyl branches are. So I need to decide, should I count from the left hand side being carbon number 1, or should I count from the right-hand side as being carbon number 1? I want to choose the lowest numbers possible. So if I start from the left-hand side, it'd be 1, 2, 3, 4 dimethylpentane. And if I start from the right-hand side, I have 1, 2, 3, 4, 5. And that would give me 2,3 dimethylpentane. And 2,3 is lower numbers than 3, 4. So the name is going to be 2,3 dimethylpentane. Cycloalkanes are essentially a chain that the two ends are connected to each other. So we have a hydrocarbon, but instead of just being a straight chain, it's going around in a circle. The smallest one you could possibly get to have a circle would be a propane. And so it's a propane that is connected in a circle, so we call it cyclopropane. So anytime we're dealing with cycloalkanes, we just use that prefix of cyclo in front. Realize this does change the formula because in order for these two carbons to connect, they're each going to have to give up a hydrogen. So we're going to be short 2 hydrogens from what we'd have in a linear alkane. Benzene's a special one that you should know is that we have essentially 6 carbons connected to each other in a circle, but they also have every other pair of carbons has a double bond. And what's interesting is that if you had this structure, I could draw the double bonds in either of these two configurations, and essentially we have resonance between the two configurations. And so we show that by, instead of drawing both ways and saying, okay, it could be one or the other, we draw it like this and we say, okay, we've got these 6 carbons in a row, and there are 3 double bonds within the structure. I'm just going to put a circle like that to show that they are resonating throughout the structure. It's kind of this, as if instead of having 3 double bonds, we have 6 1.5 bond lengths. So naming benzene with some branches on them. So let's say we have our benzene and we have a single carbon sticking off of there. We call that one, as you'd imagine, this is a methyl group on it. So it's going to have that meth with a ol on it, a branched single carbon, and it is on benzene, so we'd call that methylbenzene. We put 2 of them on there, you'd imagine it'd be called ethylbenzene. 3 of them, propylbenzene. If you have more than one branch, we have to have a way of doing that. This is the old system, so you may see ortho, meta, para mentioned as to where the configuration could be. The IUPAC system is the one that we're going to be using, or you should at least know how to use the IUPAC system, if not also the prefix of the classical systems. But the IUPAC system makes a lot of sense because it just uses numbers. So wherever your first one is, that'll be carbon number 1. And if it's on the next one, so imagine you have one branch here on carbon, on that one that you call carbon number 1. And if there's also a branch hanging off here, we're going to call that 2. So we'd say 1, 2. If we had a branch over here, we'd call that 1, 3. If we had a branch on the other side, we'd call that 1, 4, and it should make sense, 1, 2, 3, 4 all the way around. Now, this is not called 1, 5 because, again, these molecules, they can be flipped around. So this is really just 1, 2, and a third one here. So it is not 1, 5, it is just 1, 3 on the other side. Just have to go, instead of going clockwise, going counterclockwise to get to that 1, 2, 3 where that other branch is. Now, these are telling you where the branches are. They're not saying what the branches are. The number of carbons, you'd have to look at that, and then you could say what the branches are. So, for example, if we had this benzene here, it's got these methyls on them. So these are methyl branches, and we have 2 of them, so we would say dimethyl. They're on benzene, so it would be dimethylbenzene, but we have to say where they are on benzene. And so let's say that this is carbon number 1, and this is carbon number 2. It'd be 1, 2 dimethylbenzene. And it doesn't matter which one you choose to be carbon number 1, because again, these can be flipped around, so it could be 1, 2 like that. Either way, if they're right next to each other, it is 1, 2, and we'd be called 1, 2 dimethylbenzene. Now you may see some of the old system used, and this is ortho or O dimethylbenzene. So that's what that 1, 2 means. You should know the IUPAC. All right, we have, there we go, 1, 3 dimethylbenzene. And again, it doesn't matter whether this is carbon number 1 and this is carbon number 3 or vice versa. That's where the branches are. So we know what they are. We need to know where they are by using the numbers. This is the old system would have called this meta or M dimethylbenzene. And this one here, again, 1, 2, 3, 4. So this would be 1, 4 dimethylbenzene. Or using the old system, para or p-dimethylbenzene. So benzene can be treated like a branch as well. So if you have a long parent, you may want to not use benzene as the branch if you have another long chain to it. So let's have a look at this one. This one, you could name it as benzene as the parent, or what we could do is we could say, okay, let's treat this as the parent. We've got 3 there. Otherwise, you're going to have to treat it as a branched branch, which can be a little bit more complicated. So let's imagine that this is a propane that has this benzene branch on it. If it is a benzene branch, then we're going to refer to it as phenol. And so methane as a branch, we say methyl. Ethane as a branch, we say ethyl. When benzene's a branch, we say phenol. So let's put these 3 here. Again, we're going to treat these ones as the parents, and we're going to say, okay, if that's the parent, and we're trying to get names as if these benzenes were the branches, and it's not that you have to do it this way. You could treat benzene as the parent as well, but if we were to treat the linear alkane as the parent, we'd get the names of, in this case here, it is a propane on the 1, 2, 3, so on the 2nd carbon, there is a benzene branch, which we call a phenol branch. For this one here, we have on the 2nd carbon, and 2, 3, 4, 5. So this is pentane. And on the 2nd branch, there's a benzene. So we'd call it 2-phenylpentane. And on this one here, 1, 2, 3, 4, 5. So it is also pentane, but it's on the 3rd one this time. So it would be 3-phenylpentane. All right. With this one here, we've got 2 branches. So again, let's treat this long one as the parent, and then we've got this methyl branch, and we've got this phenol branch. We want the branches to have the lowest number, so we have to put numbers in to say where the branches are, but we want them to be as low as possible. And so let's start counting from the right-hand side. So this should be carbon number 1, 2, 3, 4, 5, 6, because if I went the other way, my branches would be further away from carbon number 1. This way they are on carbon number 1 and carbon number 3. So I'm going to end up with a 1, 3 as my prefixes. If I count it from the other side, I'd have 1, 2, 3, 4, 5. So obviously 1, 3 is lower than 4, 5. So I'm going to start counting from the left, from the right-hand side carbon here, instead of from the left. So then the question is, what are the names of their branches? So this is a methyl branch, as we know, and this is a benzene as a branch, which we'll call phenyl, and we just need to say where they are and what parent they're on. And so this is a 6 carbon one, so it's hexane, and there is a methyl branch and a phenyl branch. Now remember, these have to be alphabetical, so you need to say that the methyl is on carbon number 3, the phenyl is on carbon number 2, and check your alphabet, but we are going to be putting our methyl first. And so we end up with our 3-methyl. So think of that as, this is the description of this branch here. It is a methyl branch on the 3rd carbon. And this 2-phenyl is a phenyl branch that's on the 2nd carbon. So it is 3-methyl, 2-phenyl, and the parent is a hexane. All right, let's look at this one here to introduce us into our next topic. Longest parent is along here, so notice the bend there. They don't have to go horizontal. It is, we're saying the longest parent, not the one that goes horizontal. We're looking at whichever one is longest. And so we are going to start counting. If you see the branches here, we have a single carbon branch, and then again we have, so it's another methyl and another phenyl. And so we would start counting our carbons from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9, so it's nonane, and there is again a methyl on carbon number 3 and a phenyl on carbon number 5, and the methyl has to come first because the M comes before P. So I'm going to say 3-methyl, 5-phenyl, and this is nonane, but the reason why we're doing this is because it has a double bond. So we're going to look at what you do when you have double bonds, because these aren't alkanes anymore. When they have a double bond, the ane ending of the parent is going to no longer be ane, and it's going to now be ene. Ene is going to be what we use for double bonds. And similar to the other naming systems, we have to say where it is, because this double bond could be anywhere in the parent. So we're going to use ene to say that it's there, and then we're going to need a number to say where it is. So the real name for this guy, and you can sort of deduce already how the system works. The 3-methyl-5-phenyl, you got no problem. Known is the fact that there's 9 of them. Ene is saying there's a double bond. You'll notice that we use the number 3 out front, and that is because it comes after carbon number 3. That's where the double bond is, and so that's what we're going to use, and we'll explain this in more detail in a second, but that's essentially we're saying after carbon number 3 there is a double bond on this 9-carbon chain. This cis we'll talk about as well. This particular diagram doesn't really show us the structure for it very well, but we'll look at that in some more detail as well. So, double bonds and triple bonds. Double bonds, we use the suffix "ene." Triple bonds, we use the suffix "-ine." And so it's still a hydrocarbon, it's just not saturated. Some of the carbons are not hanging on to as many hydrogens as they could, and instead they are double bonded to each other or triple bonded to each other. And so just change the ending from "-ane" to "-ene" if it's a double bond, or to "-ine" if it's a triple bond. So ethene, instead of being 2 carbons single bonded with some hydrogens, they're going to be double bonded to each other. That would be ethene, and then they would have the hydrogens on them as well. Realize line diagrams don't really work well for meth or eth. And then "-ine" would have a triple bond. Now, when there's a triple bond, we want to say the "-ine" ending. If it's prop, let's say, let's try drawing the line diagram for this. Triple bonds we can draw like that. This carbon and this carbon are going to be triple bonded to each other. There's 3 carbons in total, and so this would be prop-ine. Realize this carbon could have 1 more hydrogen. This carbon in the middle, it's full. It's got 3 bonds to 1 carbon and 1 to the other, so it can't hold any hydrogen. But this last carbon can hold on to 3 more hydrogens. So if there is more than one possibility to where the spot is, so obviously for ethene here, there's only one spot. There's only 2 carbons there. But if there is more than one spot, we are going to use numbers to say where those are. So let's try that out. So we've got a bunch here that are some examples, and again, not full line diagrams, especially when you only have 2 carbons. An equal sign is what it would look like if you're drawing a line diagram. So we may decide to show the carbons for some of these smaller molecules. But if we look at this first one here, we've got 2 carbons, and they are double bonded. So that first one is just called ethene. It's not ethane anymore. It's ethene, 2 carbons that are double bonded to each other. Then the next one, you can see they're triple bonded, so that must be ethine. This third one here, we've got 3 carbons. There's a double bond in there, and so this isn't propane anymore. It has a double bond, so it is called propene. And same thing as this last fourth one here, 3 carbons, prop, triple bond, so it's called propyne. We won't get into putting 2 in there yet, so let's just look at one of them, and it would just be called propene. Not that you could put in 3 triple bonds because there's not enough bonding in the carbon, but right now we're just looking at one of these things at a time. So this next one here, we've got 1, 2, 3, 4. So that's bute, but it's not all single bond. It's not a saturated hydrocarbon anymore. It has this double bond here, so it's going to be called butene. And notice the number here is going to be needed in this case because we have enough carbons. This double bond, it could have been in the middle here. So imagine these carbons in the middle are double bonded instead. It would still be bute, and it would still have a double bond, so it would be butene, but it would be in a different spot. And so the number is going to tell us where it is. If this is 1 butene, then that tells me that after the first carbon, there's carbon 1, 2, 3, and 4. After the first carbon, there is a double bond. Notice that the number generally tends to come out front, and it's referring to the ene, the double bond part. Sometimes what you'll see is that people will write the number directly in front of the suffix. So but1ene. It looks a little bit messier, but it is actually easier to understand because then the number comes right before the thing it's talking about, just like it did with our branches. So you'll see it written either way. You can develop a preference of your own and decide which way you want to write it. All right, this one here we have 1, 2, 3, 4, 5. So we're talking pent. We've got a triple bond, and it's after the second one. And again, we're trying to go for the lowest numbers. We want the thing that we're interested in to be closest to carbon number 1. So if I counted this as carbon number 1, 2, 3, it would come after the third carbon. Whereas if I count from the left-hand side, it comes after the second carbon. So I should count from the left-hand side. This should be carbon number 1. And there's 5 of them, so that is going to be pentyne. The yne triple bond comes after the second carbon, so we call it 2-pentyne. But again, you may decide, okay, I want to put that number right in front of the prefix, suffix, sorry, that it is talking about. So I'm going to call it pent2-yne, which doesn't look pretty, but it is actually easier to understand. So cis-trans isomers are when we have a double bond that is not at the end of a chain or whose parent can't be changed between two options. So let's see what that looks like. First of all, let's look at the definition of cis and trans, and then we'll talk about when it is not needed. When it is needed is when you have a double bond, the carbons cannot rotate anymore between two configurations. And so this particular one, when you have the double bond, these two carbons, so this carbon number 1 and carbon number 4, let's call them, they're locked in this configuration. Whereas if we look at this other configuration, you'll notice it is a different configuration. Carbon number 1 and carbon number 4 are also locked in this other different configuration. We refer to this top one here as cis, in that if you look at the double bond, the parent points down on either side of the double bond. That is referred to as a cis configuration. It could also be pointing up. So let's look at that option. Cis meaning the same side, and so again the parent points upwards, this one points upward, they're pointing on the same side in the same direction, and so that is referred to as a cis configuration. Trans configuration is where they point in opposite directions. One's pointing up and one is pointing down, and realize you could also have it the other way around like that. And so the first one's pointing up and the second one's pointing down. It's the same thing, just rotated. And so that particular configuration is called a trans configuration. So trans means they're pointing in opposite directions. Cis means they're pointing on the same side, is the easiest way to think about it. So we write this right before we say the number. So again, the 2 tells us that we're dealing with a double bond on the second carbon. We're coming after the second carbon. Cis or trans is going to come right out front of that number. If one of the carbons in the double bond has 2 of the same substituents to it, then you don't need cis or trans in the naming. So let's look at what that would look like. So let's deal with the same molecule here, and let us try to fit it in. So let's say we had this one here. We know that's 2-butene in a cis configuration, so we call it cis-2-butene. If it went like that, we know that's still 2-butene, but it's in a trans configuration. The parent points in opposite directions on either side, and so that is a trans 2-butene. Now, let's say we had, so again, there's cis-2-butene, but let's say we had a branch that pointed up. Now, either one, so this carbon that's up at the top there, or the carbon that's at the bottom, could be the parent, and it would still be the same length of chain, and so either one of them can be the parent. So whether you say the top one's the parent and it's in a trans configuration, or you say the bottom one's the parent and it's in a cis configuration, it would still give you the same exact molecule. So cis or trans in that case would not add anything to the naming system. It would just be called, so again, this is 2-butene, and it has a branch on it, this guy here. It's on the second carbon, so let's say this is 2-methyl 2-butene. Now, whether I called this cis 2-methyl 2-butene or trans 2-methyl 2-butene, I would still draw it exactly the same way. And so if you're getting the same exact molecule, whether you consider the bottom one to be the parent or the top one to be the parent, you would get the exact same molecule when you draw it. And what that means is you don't want to have 2 names for the same molecule. So that means you don't need the cis-trans labeling, because either way you call it, whether you call it a cis or whether you call it a trans, you'd still end up with the same molecule, which means you drop the cis-trans need of the naming. 2-methyl-2-butene is this molecule here. If you called it 2-methyl-cis-2-butene or 2-methyl-trans-2-butene, you'd still get this exact molecule there. So you don't want to have two names for the same molecule, which means we do not need the cis-trans labeling of that particular molecule. And the quick way to tell whether that is going to be the case or not is, again, if what's pointing on either side of the double bond, so in this case here, we have the double bond, you look to either side, you say, okay, is this cis or trans? Well, should I count the top one as the parent or the bottom as the parent? It doesn't matter, therefore I don't need cis-trans. All right, let's try naming these guys here. So again, find the longest parent. So if we look at this one, we could probably say that one there is the longest parent. And the thing with double bonds is that they take precedence over branches on who gets to be closest to carbon number 1. So there's this whole hierarchy as to what's the sort of more important thing to consider in the naming of organic compounds. And double bonds and triple bonds take priority over these carbon branches. And so it doesn't matter if this carbon here, it's pretty close. If we call this carbon number 1, this would be carbon number 2. So we'd get a branch number 2. But a double bond takes precedence. So no matter what that branch says, this is going to be carbon number 1 because that puts our double bond at carbon number 2, and it decides who is going to be carbon number 1. The double bond gets to be closest to be carbon number 1. So in labeling this, I have to label it from the left-hand side in the way it's drawn because the double bond has to be on carbon number 2 in this case because it is going to be a precedence over the methyl branch. So let's draw that parent again and our branch. So we've got a 5 carbon, so that's going to be pentane, but it's got a double bond in it, so we call that pentene. The double bond comes after carbon number 2, so that's going to be 2-pentene. And there is a methyl group on it, which is on the 4th carbon. So there is so again, this is a methyl part of it, and it's on the 4th carbon. This is the ene suffix, and it is after the 2nd carbon. And so we are going to be calling this 4-methyl-2-pentene. Now, cis-trans, again, be careful with the double bonds. Cis-trans configuration is something that's easy to forget. Look for the double bond, and as long as the double bond's not on the end or has a branch that would negate the parent, make the parent the same on either side, you have to consider its configuration. So this one here, look at the double bond, look at the parent, notice it goes down on both sides. It's going to the same direction on both sides, and then it keeps going. But we want to look at the bond directly on either side. That is going to be a cis configuration. So this isn't just 2-pentene, it is cis-2-pentene. And there's a methyl on the 4th carbon as well. So we would refer to that guy as 4-methyl-cis-2-pentene. All right, next one, we have a parent again. Let's choose this as the parent. Whether we went up and chose that as the parent instead, that would give us the same name, so either one will work. This is going to be carbon number 1, and this is going to be carbon number 2, because that puts the double bond closest to carbon number 1. I wouldn't want to start over here, because that would put the double bond way at the other end. So 1, 2, 3, 4, 5, 6, that's a 5. So that is hex, and it has a double bond, so it's ene. Now I want to say it's 2, because so this is my suffix of ene, and I know there's a 2 that's going to come out front, and I know this is hex, so it is 2-hexene. There's a branch on it as well. Now, careful with the isomer on this. Is this a cis or a trans, you ask? And we see that the parent on one side is pointing in this up direction. Now remember, we could have chosen this to be part of the parent, this carbon here, or this carbon here. So what that means is this could be the parent, or this could be the parent, which means you don't need cis-trans isomers. And try it. Try naming it as a cis or a trans, and then try drawing it. Is there a difference between the two? No. So you don't need the cis or trans isomers, and so this is just 2-hexene. There is a methyl on there, though, so we should say this is 2-methyl. Oh, that's messy. 2-methyl, 2-hexene, no cis or trans. No, that's not easy to see. All right. cyclopentene for that one. This one is cis-3-heptene. And this one here, giving you the view of this other group that we're going to see. Pick the longest parent chain. We want this, let's get rid of that. We want this to be carbon number 1, this to be carbon number 2, this to be carbon number 3, this to be 4 and 5. That gives me the longest chain, 5 carbons in a row. I want my double bond to be closest to carbon number 1, so it's going to come after the 2. Realize the isomer here is going to be like this. Now, a branch does go down, but this has to be a branch because this one is longer. So this has to be a cis isomer because the parent has to be this guy here has to be part of the parent since the branch continues on in that direction. So we've got 5 there. Let's erase that so we can see it better. We've got 5 there, so that is going to be pentene. There is a double bond after the 2, so we call it 2-pentene. It is in a cis configuration, so it is cis-2-pentene. There is this one we know. This is a methyl. So there's a methyl on the 3rd carbon. This is an alkane. Anytime you have an alkane, they're fairly easy to name as well. You just take the first part of alkene, a halide. And so anytime you have a halogen bonded to these hydrocarbons, we just take the first part. So this is going to be bromo. If it was chlorine, it would be chloro. If it was fluorine, it would be fluoro. And so we just take the first part of the halogen's name, put an O on it, and that's going to go out front. So that's the name of this bromine as a branch. And it is on the second one. So methyl versus bromo. Bromo is going to come out first. Let's get rid of that. So 2-bromo and 3-methyl, also messy, cis-2-pentene. Let's put the name up so we can actually read it. 2-bromo, 3-methyl, cis-2-pentene.